Welcome to the lecture Introduction to 3D Printing. This is uh, Pujari Rajesh, Assistant Professor, Department of Mechanical Engineering, Madanpalli Institute of Technology and Science. Today we are going to discuss about 3D printing technology. First, outline of the presentation is introduction about the manufacturing and 3D printing, history of 3D printing, introduction of FDM, that is fusion deposition modeling, and summary of the presentation, and then the credits and references of the sources. First, coming to introduction of manufacturing. So we all know what is manufacturing. It is a process of converting raw material into useful product or good or finished product. That is manufacturing. So you can see on the figure, raw material will be processed and it will be converted into finished good. That is the manufacturing process. So basically, there are different processes which involve making of a component from raw material to useful product without removing of any excess material, and another processes to make the component by removing of unwanted material from the raw material. So these are the major methods. One is by removing of the excess material or unwanted material. Another one is without removing of any excess material or unwanted material. These are the two kinds of manufacturing operations or manufacturing processes to convert the raw material into useful or finished goods. Now, another concept that is called additive manufacturing also trending nowadays. Additive manufacturing is nothing but making a component by adding layer by layer by layer. That we will discuss in the further lectures. Now we'll discuss about the history of 3D printing. As you can see on screen, 3D printing or additive manufacturing is the construction of a three-dimensional object. We know three-dimensional. One is like length, breadth, and height or thickness. We can say that. So we are building the materials or we are building the object from a CAD model, or a 3D like digital model by adding layer by layer. We are constructing the component layer by layer. And if you come to history of the 3D printing, the concept was described around 1940s to 1950s, the first 3D printing concept. Now, if you come to 1970s, the patents and developments of 3D printing technology were evolved. And during the 1980s, like additive manufacturing equipment and materials, to manufacture the component, material should be needed. That raw material will be sorry, the raw materials were developed during 1980s, and coming to 1990s, the classifications evolved. That is, we can make the components by using the 3D printing technology by using the different classification methods. So one is selective laser sintering, stereolithography, direct metal deposition, and fusion deposition metal. So by using these concepts or these classifications of 3D printing technologies, we can make components by using the 3D printer. And in 2000s, manufacturing industries and research industries are utilized the technology, that is 3D printing technology, in the production. Now coming to 2020s, now 3D printers have reached the level of quality and price that allows most of people to enter the world of 3D printing. So even we can like get uh, for household purpose also. So we can get 3D printers for household purpose also. These kind of like feasibilities and these kind of technologies are evolved during the 2020s. Nowadays, most of the countries, even in household also, we are using 3D printing, 3D printers to make the components. And coming to introduction of FDM. So just we have discussed about the classification of 3D printing, like uh, stereolithography technique and selective laser sintering technique and fusion deposition methodology, one of that, and direct metal deposition. So these are the different kinds of like 3D printing technologies. So first, we'll discuss about the main and important technique, that is fused deposition modeling. It's also known as fused filament fabrication, that is FFF. We can call it as like that, and is a 3D printing process that uses thermoplastic polymers in the form of wire filaments to create objects layer by layer. The process involves three main stages. In the FDM, this process involves main three stages. One is CAD modeling, another one is printing, and the final one is finishing. Now, first we'll discuss one by one, that is CAD modeling. By using the AutoCAD or 3D modeling or SolidWorks, we can create a concept or the model of a component. So, by using the different software packages or design packages like AutoCAD or CATIA or Solid Edge, by using these kind of softwares, we can prepare a CAD model. Then after that, CAD model will be used as an input for the next stage, that is printing. The melted material is extruded through a nozzle and deposited in a predetermined path over a build plate. So here the main thing, that is in between the CAD modeling and printing, there is a crucial stage that is called slicing. This one is very very important in a 3D printing technology. So this for this slicing, so as we discussed in the previous slides, this 3D printing is manufacturing a component by adding layer by layer. So here in the slicing, first we need to slice the entire 3D model into layer by layer. This will be done by using the slicing softwares like Ultimaker Cura or slicing softwares. So we have uh, you, you can get these softwares, open access softwares, cracked softwares through the internet. You can directly get and you can install it and you can use this kind of softwares, Ultimaker Cura and Slicer. So here in between, after creating the CAD model, before going to the printing, so we need to import this CAD model into Slicer software or Ultimaker Cura. Then after, we need to generate a code and we need to give some prior settings, printing settings, like layer height, layer thickness, and temperature, build plate temperature. So there are many input parameters we have to give for printing. So after setting all these like print settings, then we can go for, yeah, there are many print parameters are there, like bed temperature, printing speed, and also layer height, layer thickness, boundary conditions, and cooling temperature, and everything we need to give before going for printing. So in between the modeling and printing, that is the crucial round. So once again, I'm telling you, the first stage is CAD modeling. By using the AutoCAD software or by using the CATIA or Solid Edge, we can prepare 3D model of our required component. Then after, by using the any slicer software like Ultimaker Cura or Slicer, first we need to import the 3D component, a 3D model into the slicer software. There we need to give some prior settings, print settings, like print temperature and all. Then after, so we can click on like slice. Then The code will be generated. That code will be saved in a drive. That code will be imported to the next stage, that is printing stage. So there the material will be feeded into the machine, and the melted material is extruded through a nozzle and deposited in a predetermined path like as per the code which is generated in the slicer software, and that will be printed on a predetermined path over a build plate. And another one, that is finishing stage. So here another like important thing, the quality and the characteristics of the component will be defined here. That is, finishing is most important thing, tolerances is most important, dimensional accuracy is most important. That will be modified and that will be refined in the finishing stage. So here one more important concept, that is called support material removal. So I forgot to discuss about the support material during the slicing stage. So we can add support material. So what is support material, why we need to use support material, this we will discuss now. See, any three-dimensional objective is having like some base on the floor, or some are the like un what we can say that um, some different structures will be there. So not like properly shaped such structures will not be there in some components. So in such kind of components, so we need, during the printing, that is very crucial. Why? Because uh, if you have support on the base for the component during the printing, then it will deposited layer by layer, layer by layer. If there is if there is no uh, support to the component during the printing, then automatically the melted material will fall or will deform. So to avoid this kind of problems, so we can give support material. This may be the like printed material, or in the market support materials are available which can be soluble in a water or in chemicals, or we can easily remove by using the some grinding process or some polishing process. So that will be carried out, these finishing operations or removing of support materials will be carried out in a finishing stage. Then summary of this one, this lecture is understanding the concept of 3D printing. That is, 3D printing is a process of constructing a component by adding layer by layer, layer by layer. And coming to the classifications, there are stereolithography technique, selective laser sintering technique, direct metal deposition technique, and fusion deposition modeling technique. These are the major classifications available for 3D printing technology. Next, understanding the concept of fusion deposition model. So here the material will be in the form of filament, that is in the form of wire. This will be feeded into the machine, and this filament is melted by using the heaters and extruded through the nozzle, and it will be deposited on a board or on a plate in a predefined area. And in upcoming lectures, a detailed working of FDM will be explained with a live demonstration. How we can model, and how can we can create slicing, and how can uh, we can give the print settings, what are the in most significant process parameters in 3D printing, and what are the influences, like effects of that parameters, that will be discussed in the upcoming lectures. Thank you very much. Follow the series of lecture Introduction to 3D Printing. Thank you very much.